gonna drop these two balls. Which one will reach the ground first?
I think the football, the heavier one.
I'm gonna drop it. The both one will reach the same time.
When you drop these two balls from a height, both will reach the ground at same time, irrespective of their masses. One ball is heavier and one is light. Both will take same amount of time to reach ground. Now we will discuss why they take same time to reach the ground, why they reach at same time. So here when you drop a ball from a height, the only force acting on the ball is force of gravity. So this represents Earth. And you are dropping a ball from a height. So the only force acting on this ball is the force of gravity. By Newton's law of gravitation, force of gravity is equal to G multiplied m into m divided by r squared. So this Fg represents force of gravity, and this capital letter G, it represents the universal gravitation constant. So its value is a constant, and m is the capital letter M is the mass of Earth, and the simple m is mass of the ball, and r is the distance from the center of Earth to the center of the ball, that is the distance r. So the force of gravity is given by this equation. Then by Newton's second law, the resultant force acting on an object, that is equal to force is equal to mass multiplied acceleration. This F represents resultant force, m is the mass of the object, and a is the acceleration of the object. So by Newton's second law, the resultant force acting on any object is given by mass multiplied acceleration of the object. In this case, the only force acting on the ball that we are dropping is the force of gravity. So the resultant force acting on this ball is equal to force of gravity. So by Newton's law of gravitation and Newton's second law of motion, we can write the resultant force, that is mass into acceleration, is equal to G multiplied m divided by r squared. So here this m is the mass of the ball, and this m also mass of the ball. So we can cancel that from both sides of the equation. So acceleration of a falling object, that is equal to G multiplied m divided by r squared. So in this equation you can see the acceleration of a falling object does not depend on the mass of the object, because acceleration is equal to G multiplied m divided by r squared. This G is a constant that is called universal gravitation constant. M is the mass of Earth, and r is the distance from center of Earth to the object. So by this equation you can see that the acceleration of a falling object does not depend on the mass of the object. So if you drop a heavy object and a lighter one, then both will have same acceleration. So both will be falling at same velocity, and both will take same amount of time to reach the ground.